Okay, this is the P4 paper from October 2021. It's question number 6, and if we look at it, we can see this is an integration question, and in particular, integration by substitution. If we read through, it says, can we work out the area R here? And the area R is just going to be the integral of y dx, isn't it? Let's make a start. Let's get started with the question. Area R is equal to the integral of y dx. Between the limits, what have we got here? We've got pi over 6 and pi over 2. So we're looking for the integral between pi over 6 and pi over 2. So if we're going to do a substitution one, I always tell my students the most important part of the substitution is getting the differential. So u equals 3 plus 4 sine x means that du by dx is equal to differential of sine is cos, so for cos x there, and what do I mean by the differential? Okay, du over 4 cos x is going to be equal to dx. So this part has been taken care of, and it's been taken care of, but we've introduced a 4 cos x on the bottom. So I'm assuming I'll get a 4 cos x on the top there somehow, and yeah, if we look at what we've got there, then that's going to come about from the fact that up here, 16 sine 2x is the same as 16 2 sine x cos x, and there is our cos x on the top. So I'm just spending a little bit of time thinking about this before I actually get started properly with doing it, but we've worked out our dx, so the question is now going to be the integral between pi over 2 and pi over 6 of 16 sine 2x all over 3 plus 4 sine x squared dx. As we said here, this dx is going to be replaced by that, so I've now got to also replace this one, and don't forget about the limits. And in fact, the limits is where you can go in any order you want now, but I'll tend to focus on getting these limits sorted out before I do anything else. So at x equal to pi over 2, u, remember, is the substitution 3 plus 4 sine x. So it's 3 plus 4 sine pi over 2, and sine pi over 2 is 1, so 3 plus 4 gives me 7. Let's do the other limit at x equals pi over 6. We get u equals 3 plus 4 sine x again, but this time it's 3 plus 4 sine pi over 6. So that's going to work out to be equal to 5. So we've got our two limits now in our equation, so r is now equal to, and because they're limits for u, I'm going to call them u equals 7 and u equals 5. The rest of it, what have I got? Well, I've got 16 sine 2x all over 3 plus 4, 3 plus 4 sine x squared dx, and we can now gradually substitute in the things that we need. So u equals 7 and u equals 5. 16 sine 2x is 16 lots of 2 sine x cos x. The 3 plus 4 sine x being replaced by u, I can do that now, so u squared, and the dx I can replace with du over 4 cos x. So we can see now that this cos x and this cos x are going to cancel, which gives me the integral between u equals 7 and u equals 5 of 32 sine x all over 4 u squared du. So our one big issue now is the fact that I've got sine x in the middle of all of that, but that's no problem at all because sine x we can get from simply rearranging here. So let's just show the examiner what we're doing. I think I'm taking lots of steps here. I don't know that I'd necessarily do all these steps if I was doing it for my own purposes. So for sine x equals u minus 3 over 4. You do it as quickly as you can by maintaining a level of accuracy when we're actually doing all this. So tidying all this up then, I don't need to say u equals 7 and u equals 5 now because I'm only going to have u's in this bit. When I stick in u minus 3 over 4 for sine u, and then I've got 32 over 4 u squared du, all of that tidies up. And as I say, I'm taking lots and lots of steps here, I think. What have we got there? We've got 32 over 16, so that's 2. I'm going to leave the 2 on the outside here. I've got u minus 3 over u squared du, which is, I can split that up into the 2 parts now. U over u squared is u to the minus 1, and then 3 over u squared is 3u to the minus 2 du. So I've finally got it into a stage where I can actually now go ahead and integrate this. I'm not going to spend any time doing that, adding 1 onto the power, dividing by the new power for that one there. And obviously the integral of 1 over u is log u. If those things, if this step here, getting this situation is not really straightforward to you, you need to go back and do some more work on your integration. So just integrating that gives me that. Now if we go back, I haven't mentioned this yet, but they will do this quite often. That's a bit nasty, the fact that they've told me to write it in a particular format. So what I do need to just be careful of is as I'm going through here, I'm just going to put 7 and 5 in. So I'm going to get 2, and then I'm going to get log 7 plus 3 over 7. Minus log 5 plus 3 over 5 here. Let's sort out those brackets actually. That's just a bit neater to do it like that. So sticking 7 in and then sticking 5 in. So I've got to combine the logs. Log 7 minus log 5 is log 7 over 5. And then 3/7 take away 3/5, and do that on the calculator obviously, is 6 over 35. But even that would not be good enough now as an answer. I've now got to have it in the format they want. So 2 log 7 over 5, 2 log 7 over 5, we can make that log 7 over 5 squared, can't we? And 2 lots of 6 over 5 is that one then. Either that, or I suppose you could actually write that as log 49 over 25 minus 12 over 35 there. And that is the answer and in the correct format. So hopefully that all makes sense.